The topic of our project is series RLC circuits. In our project, we will be dealing with its response to DC and AC, some properties of a series RLC circuit, and its applications in real life.
Now here we can see there is a series RLC circuit. The question arises that what will be its response to a DC source? It will not show any response to DC source because capacitor is open circuit to DC. Therefore, there will be no current flowing through the circuit. The response to AC can be found by applying Kirchhoff's voltage law to the circuit. Thereafter, dividing the equation by inductance and differentiating it with respect to time, we get a second order differential equation. In this equation, we can replace R by L with alpha, which is Neper frequency or a measure of how fast transient response will die out. Omega naught is the resonant angular frequency of the circuit. The ratio of alpha to omega naught is represented by zeta, which is the damping factor or the ratio of attenuation to resonant frequency.
What is an electrical transient? An electrical transient is a temporary access of voltage or current in an electrical circuit which has been disturbed. It is a response of a system to a change from equilibrium. The transient response is not necessarily tied to on or off events, but to any event that affects the equilibrium of the system. These are short duration events lasting for few seconds. They are divided into three parts: overdamped response where zeta is greater than 1, underdamped response where zeta is less than 1, and critically damped response where zeta is equal to 1. In the graph you can see the transient response of various underdamped, overdamped and critically damped circuit as a return to equilibrium. Underdamped versus overdamped. The response can be classified as one of the three types of damping that describes the output in relation to the steady state response. An underdamped response is one that oscillates within a decaying envelope. The overdamped response is a decay of transient current without oscillations. The critically damped response represents the circuit response that decays in the fastest possible time without going into oscillations.
Let's discuss about impedance in a series RLC circuit. As we know, every element opposes the flow of current. In case of resistor, it's called resistance. In case of capacitor and inductors, it's called reactance. Inductive and capacitive reactances oppose each other as inductance voltage and capacitive voltage differ by a phase angle of 180 degree. The combined effect of resistance and reactance in an RLC circuit is known as impedance. Resonance in a series RLC circuit. At a particular frequency, when the capacitive and inductive reactance become equal, that is when the impedance is minimum and series RLC circuit is said to be at resonance. Since they are in opposite direction, they cancel out each other and the circuit becomes purely resistive, thus minimizing impedance. Due to this, the current in the circuit is maximum. Such a circuit is said to be a series resonant circuit and the frequency is called resonant frequency.
Now that we have studied various properties of a series RLC circuit, let's look at some of its applications. Series RLC circuits are used in a variety of electronic gadgets such as filters, radios, speakers, oscillating circuits, voltage multipliers, pulse discharge circuits, etc. We are going to elaborate on a few of them. Bandpass filters. The most common practical application of a series RLC circuit is the bandpass filter. A bandpass filter is a device that only allows signals of a particular frequency range to pass through it. This happens because the reactance of capacitors and inductors change for different values of frequency. Therefore, the capacitor will allow high frequency signals to pass through and attenuate low frequency signals, while the inductor will do the reverse. The frequency range that is passed through the unattenuated is called the passband.
So, I will be showing you how a bandpass filter works with the help of a graphic equalizer. A bandpass filter is a device that allows signals of a certain bandwidth called passband to pass through and attenuate signals whose frequencies lie outside this bandwidth. As you can see here on the equalizer, there are many frequencies ranging from 32 Hz to 16 kHz. Now let us hear the sound clip at normal frequency levels. Now let us increase the levels of the higher frequencies and decrease the levels of the lower frequencies, thus creating a high pass filter wherein the high frequencies are allowed to pass through and the lower frequencies get attenuated. As you heard, the sound clip lacked bass and had a high treble sound. Now let us increase the levels of the low frequencies or the bass frequencies and decrease the levels of the high frequencies or treble frequencies, thus creating a low pass filter wherein the higher frequencies are attenuated and the lower frequencies are allowed to pass through. As you heard, with the high frequencies attenuated and bass frequencies increased, the sound clip sounded very bassy. Now let's select a pass band, say from 500 Hz to 2 kHz, and as we increase the levels of these frequencies, we decrease the levels of the other frequencies so as to attenuate them. As you noticed in the track, only the selected frequency range was clearly audible as the other frequencies had been attenuated. In passive audio crossover circuits in speakers, filters are used to determine which signal will go to which driver, such as high frequencies should go to the tweeter and low frequencies should go to the woofer, and so on. That's all, folks. Hope you enjoyed the show.